going over this physics problem. So to begin, the nefarious Darth Vader is taking his pet AT-AT for a walk. His AT-AT weighs about 11,200 kilograms. And I'm going to circle this. Darth Vader pulls the leash with a force of 50 newtons at an angle of 30 degrees above the horizontal. If the coefficient of kinetic friction is 0.29, what is the acceleration of the AT-AT? So before we begin the questions, you can see that I have circled all the numbers and what we need to find in this question. So let's begin first with drawing a free body diagram. So I'm going to start by just drawing the box and then just drawing all the forces that are inside it, or all the forces that are acting on the AT-AT. So the first force that we have is going to be the applied force, which is at an angle. So it's going to be FA, and this has, since it's at an angle, there are going to be two components to it, the vertical and the horizontal. So there's going to be a vertical component of the force, and there's going to be a horizontal component of the force. So I'm going to label this as, I'm going to move this over. So I'm going to label this as FA. This is FAY, and this is FAX. Next, I'm going to draw the other forces that are acting on this AT-AT. So one of them is right here is the FN, and the other force that's acting on it is FG. And then lastly, we have FK, which is pointing back, which is the force of kinetic friction, or force of, yeah. Now, another thing I'm going to define is my, what I set to be positive. So I'm going to set the top direction and the right to be positive. So anything in the opposite direction is going to be negative. Okay, so let's begin. So I'm going to solve the force. I'm going to solve for the first force, which is here, Fg. Now Fg is given by mg. So we know that the mass is 11,200. I'm just going to multiply those two by, so I'm going to multiply 11,200 by the force of gravity, which is 9.8. Now, according to our convention, force of gravity is pointing down, so it's going to be negative. So I'm going to add a negative sign right here. And when you multiply those two, we get minus 109,760 newtons. Okay, so this is our force of gravity. Next, I'm going to look at the force applied and the force applied on the y and the x. So the force applied on the x is given by 50 times cos 30. And that is 43.301 newtons. And the force applied on the y is 50 times sine 30, which is 25 newtons. Y is the x cosine and y sine. Well, if you look at this, we can see that this is 30 degrees. So the y would be sine, since this is opposite over hypotenuse, and the x would be cosine, since this is adjacent over hypotenuse. And that's where we get these two values being cos and this value being sine. Next, I'm going to solve for the F net on the y-axis. And the forces that are acting on this is Fn plus Fg plus Fay. And the Fn we don't know. And we also know that the AT-AT is not moving vertically, which means the net force is 0 on the y-axis. So Fn we don't know. I'm going to put that as our variable. Fg we know is minus 109,760, and Fay we know is 25 newtons right there. So when I simplify the right side, I get Fn minus 109,735, and then I'm going to bring this on to the left side. So Fn is now 109,735 newtons. 735 newtons. Notice that it's now positive. Next, I'm going to solve for the Fk. Now the Fk is given by mu Fn. We know Fn from the previous part of the question, and we know mu. So I'm going to plug that in and solve for Fk. And I get 31,823.15 newtons, and this is pointing left. Next, I'm going to solve for the Fnet on the x-axis. Now, the question asks for acceleration, which means that the AT-AT is moving, but it's also moving on horizontally, not vertically, which means Fnet x cannot be 0, unlike Fnet y, which is 0, because the AT-AT is not moving up and down, it's moving left and right. So there is motion on the vertical, there's motion on the horizontal component, not the vertical component. So I don't know what Fnet x is, so I'm going to solve for that by first listing all the forces that are on the x-axis. So there's Fax and there's Fk. Now Fax, which is what we solved earlier up here, is 43.301 newtons, and Fk is 31,823.15 newtons. Now notice that this is negative because we said that Fk is positive going left, but since Fnet x is to the right and we consider Fax to be going to the right, this is positive, this is negative. And Fk, since it's on the opposite direction, is going to be negative. Now when I simplify this, I get Fnet x to be minus 31,779.85 newtons. Also do note that I'm not rounding everything and writing it as I see it, and then we'll round it to the number of significant digits later. So now that I have the Fnet x, I'm going to solve for the acceleration. So we know that acceleration, it can be found by this equation. Fnet x is equal to mass times acceleration. And I know what the Fnet is on the x-axis, 779.85. This is equal to 11,200 acceleration. And if you divide the mass, the Fnet by the mass, A to be minus 2.84 meters per second squared right, or A to be 2.84 meters per second squared left. And to end by therefore statement, the acceleration of the AT-AT is 2.84 meters per second squared to the left.